Okay, let's take a look at example number 8, where we're going to be using the L'Hopital's rule with an improper integral. So we're going to evaluate the integral with a function of natural log of x dx, going from a lower limit of 0 to 1. Now, we know that the function f of x is equal to natural log of x has a vertical asymptote at 0, since the limit as x approaches 0 from the right of the natural log of x is equal to negative infinity. Thus, the given integral is improper, and we have the following. So we're going to take this original integral, and then it's going to become the limit as t approaches 0 from the right, with the lower limit of t and upper limit of 1 of the natural log of x dx. Now we're going to integrate by parts. So we're going to let u equal the natural log of x. We're going to let dv equal dx. Therefore, du is going to equal dx divided by x, and v is going to equal x. So now we're going to apply the integration by parts, uv minus the integral of v du. So we have x times the natural log of x going from t to 1 minus the integral going from t to 1 dx. Evaluating this integral, we get 1 times the natural log of 1 minus t times the natural log of t minus 1 minus t. Combining like terms, we get negative t times the natural log of t minus 1 plus t. So now we need to look at this first term here. To find the limit of the first term, we're going to use L'Hopital's rule. So we're going to take the limit as t approaches 0 from the right, t times the natural log of t, which is equal to the limit as t approaches 0 from the right of the natural log of t divided by 1 over t, which is equal to the limit as t approaches 0 from the right of 1 over t divided by negative 1 over t squared, which equals the limit as t approaches 0 from the right, negative t, which ultimately equals 0. Now, since we know that that's going to give us 0, now we can go ahead and apply the limit rule of all three terms. So the limit as t approaches 0 from the right of negative t natural log of t is going to give you negative 0. This is a constant, so it's going to be negative 1. And we know that this positive t is going to be 0. So combining all these, we're going to get negative 1. Now, if we take a look at this figure, it's going to show the geometric interpretation of this result. So the area of the shaded region above the natural log x and below the x-axis is 1.